Knowing concentrations of solutions is extremely useful information. But how is this determined? And how can we determine this in the lab? For today's experiment, we will be using phenolphthalein. Now write that down. You may need several attempts. Your equipment should look like this. Be prepared to write this down. Notice, the burette has been positioned upright and leads into the conical flask. The conical flask itself has been placed on the white tile to allow noticeable colour changes, and the tap of the burette has been positioned to close to prevent excess acid leakage. Ensure your equipment is set up as shown in the diagram. Unlike this, notice how superfluous equipment has been used. The measuring cylinder has been positioned upside down and is not necessary for this experiment. Both the deionized or pure water and the conical flask have been badly placed. The super burette is not suitable for this experiment, and although the acid solution has been clamped securely, which is good safety practice, it is not practical in this situation. Now put on your goggles. Preferably the right way up. Ensure safety precautions are in place, asking your teacher if you are unsure of proper safety practice. Measure out 25 centimeters cubed of the NaOH solution with the correct instrument and place it in the flask. Not this kind of instrument. Although the oboe sounds nice, it is not precise enough and may become damaged. Use a volumetric pipette. You may have to pour out the solution into a beaker, as the pipette could not fit. Then place your solution in the conical flask. Adding a few drops of phenolphthalein. Now write that down. Ensure acid is placed in the burette, as alkali can damage these extremely useful instruments. Now, ensuring the tap is closed, fill the burette with acid. A funnel should be in place to reduce the spillage potential. Fill slightly above the top of the scale, but not too far, else the whole filling procedure will have to be repeated. Now, allow the acid to run through into a separate beaker until the meniscus is level to the 0 mark. The titration can now begin. Now write that down. First, perform a rough titer to obtain an estimate of where neutralization will occur. Then, using this value, perform another titer, allowing acid to flow a few drops at a time, swirling the conical flask vigorously in between the addition of acid. Repeat until concordant results within 0.1 centimeters cubed have been achieved. It may take you several attempts. After each titer, rinse the conical flask thoroughly with deionized or pure water before refilling with the unknown solution. Now perform your calculations, asking your teacher if you are unsure of proper calculation methods. You should now have determined the unknown concentration. If, however, no acid was required for neutralization, your solution must have been water in its purest form. Pure water.